Okay, so now we are moving on to a little bit harder factoring. It's called AC method. And again, these are trinomials, but the leading coefficient, this a value, is not 1. So it says a does not equal 1. So the leading coefficient is 6. And if you look at the three terms, the 6 cannot be factored out. So we can't even get a leading coefficient of 1 by factoring out the leading term. So when this happens, you try to factor it with AC method. Step number 1 to AC method is to take your three terms and turn them into 4. Keep in mind that the first term and the last term must stay the same. And then the reason why it's called AC method is because you're going to take the A value, which is 6, times the C value, which is -6, and that's a value of -36. So I call that my AC. So just like before, you want to find two numbers that multiply together to equal -36. And then the middle coefficient, your B, is 5. So you want them to add up to +5. So 36 has a lot of factors. We can list them down here. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 times 6. So there's a lot of factors of 36. Since the 36 is negative, so they have to multiply together to equal a negative number, the signs must be different. One's going to have to be positive and the other is going to have to be negative. But when you're adding the numbers together, they have to add up to a +5. So whenever I have a negative, whenever my C or AC is negative, I try to ask myself, well, what two numbers multiply together to equal 36, but subtract or have a difference of 5? So as I'm looking at these factors of 36, I realize, oh, 4 and 9, they have a difference of 5. And if I want the sign, in order to multiply them together to equal a negative, your signs must be different. But I want them to add up to a +5. So that tells me the larger number must be 9. And the smaller number, which is 4, is going to have to be negative. So if I check it, if I multiply 9 and -4 together, it will be a -36. But if I add them together, I get +5. So knowing those two numbers now tells me what the coefficients of these middle terms are going to be over here. So I'm going to have a +9g and a -4g. Combine those two together and you'll get the +5g that you have in the middle. So now we move on to using factoring by grouping. Because we have 4 terms, we're going to split these terms down the middle. So we're looking at these two terms here and these two terms here. And again, you're going to ask yourself, well, what can I factor out of these first two terms? So 6 and 9 can both have a common factor of 3 because they can both be divided by 3. They also both have a g. So I'm going to factor out a 3 and a g and put it out front here. And then just like before when factoring out a greatest common factor, you're dividing 6 by 3, which leaves you with 2. You're taking the g squared and factoring out a g, which will leave you with a g. And then the 9g divided by 3g is a +3. And there won't be a g here because you're factoring it out. And if you multiplied this back together, it would equal what you started with. Now moving on to the next two terms. When this is a minus, you bring down a minus. 2 and 6 are both even, so you can factor out a 2. And then since there are two terms here, you're going to have two terms here. Divide each term by -2 because you're factoring it out. -4 divided by -2 is +2. The g is not being factored out since the 6 does not have a g with it. But now to figure out what number goes here, you have to divide the -6 by -2, which is +3. And once again, the two binomials are the same. So think of this as one group, think of this as one group, or think of this as one term, think of this as one term. What do they both have in common? The 2g plus 3. So we factor out the 2g plus 3, and then the 3g minus 2 gets put together in the other parentheses. And if I were to test and see if this multiplied together to equal what it started with, it would, because your 2g times your 3g would be the 6g squared that's in the front. Your last term, the 3 and the negative 2 multiplied together would equal the negative 6, that's your third term. And then the 5g comes from multiplying the outside and the inside terms together. So the outside terms multiplied together would give you negative 4g. The inside terms multiplied together would give you the positive 9g, which together will equal the 5g that's in between. So these are factors of that trinomial, and they cannot be factored anymore. All right, so I have 4 examples of AC method here. I'm going to go down to this example C, and then example A down here, and B. And then I'll come back up and do B and D if you feel like you still need some more practice with AC method. All right, so as I said before, whenever you have a leading coefficient that is negative, you must factor out the negative. So let's choose this color. So I'm going to factor out a negative 1. If there's anything else that you can factor out, like if all of these were even, or if they all had an x, then of course, again, you would factor that out with the negative 1. But this is kind of boring. It doesn't have anything other than a negative 1 to factor out. So I'm going to put a negative 1 on the outside. Since there are 3 terms here, there must be 3 terms in our parentheses. So when you factor out a negative 1, it's just going to change all the signs because you're dividing all of these terms by negative 1. So your 12x squared becomes, your negative 12x squared becomes positive, your positive 17 becomes negative 17x, your negative 6 becomes positive 6. So now that we've factored out the negative in front, that negative is still going to be part of our answer towards the bottom, but if we look at our trinomial here, there's nothing else that we can factor out. The leading coefficient is not 1, so we're going to, again, attempt to factor this with AC method. So I'm going to multiply, I'm going to rewrite this. I'm going to have 4 terms, right? Changes from 3 terms to 4. The first term stays the same. The last term stays the same. And then when you multiply your A times your C, so 12 times 6 would be a positive 72. I'm going to sneak that in there. So that's my AC value. And again, it's positive 72. My B value is negative 17. So I'm trying to find 2 numbers that multiply together to equal 72, actually a positive 72, but also add up to a negative 17. Since the 72 is positive, I know my signs have to be the same. But since the 17 is negative, they must both be negative numbers. So again, if we listed the factors of 72, there are a lot of factors of 72. So rather than list them all, I'm going to just, hopefully all of you are thinking of 8 and 9, or 9 and 8, doesn't really matter. But these are now going to be the coefficients for the terms in the middle. So negative 8x. Now you do have to put the x with it to get that negative 17x there. And then negative 9x. So combined, those will equal the negative 17x that are in the middle. So now we're going to factor by grouping. So we're going to separate the first 2 terms from the second 2 terms. Look at the first 2 terms now only. What can you factor out? Well, they can both be divided by 4 and by x. So I'm going to factor out a 4x. And then when I do factor out or divide both of these terms by 4 and by an x, I should have 2 terms left over. Since I had 2 terms here, I'm going to have 2 terms here. 4x, 12x squared divided by 4x is 3x, and negative 8x divided by 4x is negative 2. And if I were to check those terms by multiplying the 4x back in with it, you would get what you started with. The next two terms, again, pay attention to this sign. That sign is brought down. Both 9 and 6 can be divided by 3, so we're going to factor out a 3, but not just a 3, a negative 3. So I'm dividing both terms by negative 3. Since there were two terms here, there must be two terms here. Negative 9x divided by negative 3 is a positive 3x, and then 6 divided by negative 3 would be negative 2. So once again, it's interesting that we have, pick a nice minty green. All right, so we've got two binomials here that are the same. So we are going to factor out that common binomial. So we're factoring out a binomial. And then the 4x minus 3 goes together. And again, now it is factored completely. If you were to check this by multiplying the outside terms, so the 3x times the 4x would be the 12x squared that we had up here. Now, oh, you know what I forgot? I forgot the negative 1. So when you factor a greatest common factor out in the beginning, you do need to include it as one of the factors at the end, because it is a factor of the original trinomial. So yeah, good thing I noticed that. Somebody probably would have commented on that. All right, so that's one that was a little bit harder. Okay, and then we're going to do these two examples down here. Let's use green. All right, so this one again says factor completely, but I'm going to include more than one type of factoring involved in these problems. So again, the first step is to always look for factor out a GCF, or greatest common factor, if there is one. So both of them are even numbers, so I know 2 goes into it. But if I try to take out a 4 from 50, that's not going to work. So I believe that 2 is the largest number we can factor out of both of these terms. Again, since there are 2 terms here, there are going to be 2 terms here. When you divide each of them by 4, you're going to get 4d squared minus 25. Now this is it's 2 terms, but both terms are perfect squares. So it is a difference of 2 squares, which can be factored again into 2 binomials. The square root of 4d squared is 2d, and that 2d times that 2d equals the 4d squared that we had in the beginning. And then the square root of 25 is 5. But since it's a negative 25, one of these must be a positive, one of these must be a negative. And again, if you were to multiply this back together, your outside terms, 2d times negative 5 would be negative 10d. On the inside, you would get positive 10d, which is 0. So negative 10d, positive 10d, which cancels out, which is why there's no middle term in the first place. So now it is factored completely. And last but not least, this example B here, if we look at the first terms, again, factor out the GCF. Oh wait, timeout. I want to go back to the last one. So factoring out the greatest common factor is what we did first. And then we factored a difference of squares, or dots, difference of 2 squares here and here. So just so you kind of see where those things are coming from. All right, so now going on to the next one. Again, we're going to factor out a GCF. So the greatest common factor in these 3 terms would be 3. So factor out a 3 from all 3 terms, and you'll have x squared minus 4x minus 12. So again, you have 3 terms here. There must be 3 terms here. Now, every once in a while, you might have to put a 1 in for the constant. That does happen quite a bit. But if there's 3 terms, you have to have 3 terms, even if it's a 1. All right, so now we look at the three terms that are in this parentheses. The leading coefficient is 1, so we do not have to use AC method. We can go right to our two binomials if this is factorable. So your x squared factors into x and x. And then again, if we want to do this crisscross thing over here, the C is -12, the B is -4. In order for them to multiply to equal the -12, if it's negative, the signs have to be different. One has to be negative, one has to be positive. And if you think of your factors of 12, 1 and 12, oh, okay, uh-oh. What am I going to do? Uh-oh. Okay, let me pause this. All right, it doesn't want to erase. Okay, I'm just gonna kind of everybody saw that, or just maybe we'll just ignore it. Okay, so I'm gonna go over here, oops, and try that again. So -12 and -4. All right, so they have to multiply together to equal -12. Since it's negative, your signs have to be different. But the larger one is going to have to be negative in order to get this middle term to be a -4. Your factors of 12 are 1 and 12, 2 and 6, 3 and 4. So if we look at our factors of 12, in order to get a -4, they have to have a difference of 4. So 2 and 6 have that difference of 4. If 6 is negative and 2 is positive, then they will add up to -6 or -4, and they would multiply together to equal -12. So that tells us that these are the other terms in our binomials, and now it's factored completely. Okay, so if you are good with your factoring, you can stop taking notes here, but if you'd like, I'm going to go back up and do these couple more problems with AC method, because I know a lot of students have difficulty with that. All right, let's change the color here to purple. All right, so example B, again, has three terms. There are not any common like terms in all three of them. So we're going to start with setting up our four terms. Your first term stays the same, and the last term stays the same. When you multiply the A times the C together, you get a +30. So over here, we want to multiply two numbers together to equal 30, a +30. But their middle term, our B value, so this is AC, that's B. B is +11. So this is one of the easier ones. Think of two numbers that multiply together to equal 30 that add up to 11. So +5 and +6 will multiply together to equal +30 and add up to 11. So these are the coefficients for our middle terms. So now that we've figured out what our middle terms are going to be, we're going to factor by grouping. So again, I just like to put a little line through those terms, separate them, factor out now the greatest common factor between the first two terms, which is x, and then you'll have 3x plus 5 left over. Again, you had two terms here, so you must have two terms here. In this next two, the third sign here is brought down. Both of these terms are even, so we can factor out a 2. Again, since there's two terms here, there must be two terms here. Divide them both by 2, and you get 3x plus 5, just like you have over here. So again, think of this as one term, think of this as another. They have a common binomial. So we factor out the binomial, 3x plus 5, put the x plus 2 that's left together, and those are the factors of the trinomial. And again, if you're not real confident, you can always mentally take the 3x times x, which gives you 3x squared. Take the 3x times a 2 off to the side maybe, that's a positive 6x. The 5 times the x is the positive 5x. Together, that equals your 11x, which is your middle term. And then your 5 times your 2 does give you the 10. So these do multiply together, which is why they are factors of that polynomial. All right, one more, and we are done with notes for today. Again, look for greatest common factor. There aren't any. There are 3 terms. Your leading coefficient is not 1. So we're going to set up 4 terms. Your first term stays the same. Your last term stays the same. And then if we multiply our A times our C, we've got negative 72. So that's AC, and our B is 6. So off to the side over here, I will put my negative 72 and my positive 6. So because the 72 is negative, in order for the 2 numbers on either side to multiply together to equal a negative, your signs have to be different. One has to be negative, one has to be positive. So when signs are different, I try to think of 2 numbers that have a difference of 6. So they have to multiply together to equal 72, but they subtract or have a difference of 6. So if you're not familiar with your factors of 72, make a list. 1 and 72, 2 and 36, 3 goes into it 24 times, 5 does not go into it, 6 does go into it 12 times, and then 8 goes into it 9 times. So these are all the factors of 72. So again, since it's negative, I want to find 2 numbers that multiply together to equal 72, which all of these are, but they subtract or have a difference of 6. So that's the 6 and 12. If I want them to add up to a positive 6, the bigger number, which is 12, will have to be positive. The smaller one will have to be negative. So now if I check it, multiplied together, they do equal negative 72. Added together, they do equal positive 6. So these are the coefficients of our middle terms. And if we combine those 2 terms, we would get that middle term there. So now, once again, we factor by grouping. Separate your first 2 terms from your second 2 terms. Look at the first 2 terms. Ask yourself, what can you factor out? I can factor out a 3 and an x. And since I have 2 terms here, I must have 2 terms in the parentheses. When I divide 9 by 3, I get 3. When I take the x out from the x squared, I'll still have an x left over. Negative 6 divided by 3 is negative 2. And then I factored out the x, so the 2 will not have any x's. Also, if you check it by multiplying it back together, it should equal what you started with. All right, again, the third sign should be brought down. What 2 numbers do these 2 can go into both of these numbers? 4 goes into both 12 and 8. And then again, since there are 2 terms here, there should be 2 terms here. 12 divided by 4 is 3. There's still going to be an x, so that when you multiply them together, you get 12x. And then divide the negative 8 by 4, you get negative 2. Again, imagine this is one term, imagine this is another term. They both have a 3x minus 2, so that technically is being factored out. And then the 3x plus 4 is what you have left of both of those terms. And now we have factored completely. And those are the end of the notes for factoring review. Now work on the 20 practice problems that you have and take pictures and submit them to your Google form. Good luck.